Faraday's first law of any change in the magnetic field of a coil of wire will cause an EMF to be induced in the coil. This EMF induced is called induced EMF, and if the conductor circuit is closed, the current will also circulate through the circuit, and this current is called induced current. Method to change magnetic field. By moving a magnet towards or away from the coil. By moving the coil into or out of the magnetic field. By changing the area of a coil placed in the magnetic field. By rotating the coil relative to the magnet. In this experiment, Faraday takes a magnet and a coil and connects a galvanometer across the coil. At starting, the magnet is at rest, so there is no deflection in the galvanometer. I.T needle of galvanometer is at the center or zero position. When the magnet is moved towards the coil, the needle of galvanometer deflects in one direction. When the magnet is held stationary at that position, the needle of galvanometer returns back to zero position. Now when the magnet is moved away from the coil, there is some deflection in the needle but in opposite direction, and again when the magnet becomes stationary, at that point with respect to coil, the needle of the galvanometer returns back to the zero position. Similarly, if magnet is held stationary and the coil is moved away and towards the magnet, the galvanometer shows deflection in similar manner. It is also seen that, the faster the change in the magnetic field, the greater will be the induced EMF or voltage in the coil.